The circuit that is shown on the screen here is called an inverting amplifier. Okay, and in the inverting amplifier, you can notice that the non-inverting terminal is connected to the ground, and the feedback is applied to the inverting terminal, and the input is applied to one of the resistors in the feedback. Sometimes this resistance is called the input resistance, and this resistance is called the feedback resistance. Okay, so let's apply the rules for analyzing an ideal op amp to find out the output of this circuit. So we know the voltage here is 0. Now we also know that in an ideal op amp, if the output is finite, the voltage at the non-inverting terminal and the voltage at the inverting terminal are the same. So the voltage here is also going to be 0, right? So this is 0 volts. Now, if we have a current I1 flowing through resistance R1, and we have a current, let's say I2 flowing through resistance R2, what's the relationship going to be between I1 and I2? They will be the same, right? Why are they going to be the same? Because this current is going to be 0. And that's another of the ideal op amp assumptions that we have made. Okay, so if that is the case, we can write the equations. We can write I1 equal to I2. And what's the equation for I1? I1 is simply V in minus 0 over R1, and I2 is 0 minus V out over R2, right? This gives us V out equal to minus R2 over R1 V in. And you can see that the gain of this amplifier is minus R2 over R1. There's a negative sign here, and that's the reason why this amplifier is called an inverting amplifier. Now, the same kind of rules for selecting R1 and R2 apply for the inverting amplifier as well. We discussed these rules in the previous video with the non-inverting amplifier design, right? But there is one more reason why in this case you want to be a little bit careful as to what resistors you would be using. Now, and the way to think through that is to think where this I1 comes from, right? This I1 is going to come from a source, right? Some source has to generate this V in, and that source has to be able to give the current I1. Now, if R1 is very, very low, then you will have a very high current I1, and that current may not be able to be supplied by this source V in, and that kind of limits your choice of R1 and R2.